All right. So from the last class, we started off with relative formula math or MR. We studied the names for MR, but really we use them in relative formula math because that's the most appropriate term. You might hear relative molecular math or relative ionic masses or other words there too, but this exact is the best part of it. That's the best name. This name will have no technical problems with it. It's actually the same one. We actually find out the mass of the whole molecule, doing it atom by atom and comparing every atom with the carbon 12 scale. The denotation is capital M and R as a subscript. We started off with simpler examples, and the first example we have over here was MgCO3. We understood this one. Then in the very next example, we have a jump up how to deal with parentheses. In case of parentheses, it's pretty simple. The number written below the parentheses as a subscript actually multiplies with everything inside, whatever the number written below as a subscript to the element is. Now, remember, make sure you use the right and atomic masses value from the periodic table as given in the hint over here. Next question is again a jump up. We understand the water crystallization. We understand that some salts are known as hydrated because they have a specific number of water molecules attached to them. But when we write them in the formula, we really use the dot over here. While calculating MR, this dot acts as a plus or an addition factor. So we add the number of mass of water molecules to the mass of the salt, and then we calculate the total MR. Now, again, the hint, it is dangerous to calculate number of hydrogens and oxygens separately. If you memorize that the mass of water is 18, it's pretty simple to multiply that 18 with the number of water molecules. Remember, as given in the diagram over here, water molecules are fixed for every salt. And for different salts, the values are different. For example, for CuSO4, the value of number of water crystallization molecules are 5. For Na2CO3, that's 10. For MgCl2, that's 6. And even for a single salt, there can be different values at times. So this gives us the idea how this goes. Moving on, the very next topic was to find percentage composition, and we did percentage composition for elements. For example, in this formula of CuO, the whole mass of or MR of which comes out to be 79.5. The percentage of copper would be 79.9%. Of course, if we subtract 100, this percentage from 100 will get the percentage of oxygen. So it's really easy. If you want to find out the percentage of oxygen, you can either go with 100 minus 79.9 and get your answer. All right. Or you
Mhm.
can go with the formula for oxygen. It's really simple. You can divide 16 by 79.5, multiply by 100. It's either way you can do it correctly. Now, this method ensures that you get the exact answer because this method depends upon the answer from this one. If you made a mistake over here, obviously you're going to make a mistake over here too. So it's better to calculate every percentage separately rather than just subtracting it from 100. So that's another good way that we didn't discuss on the previous day. Then there are other examples. We have the example of Na2CO3 over here. We need to find out oxygen. This was rather an easier example, and the topic continues on the next page with something else. So I came up with another example of mine so that you can go with something a little bit more difficult. We discussed that K2SO4, Al2SO4 thrice dot 24H2O, the bigger example for Mohor salt, and I hope you're able to do that. Now, apart from that, there can be a little bit of a manipulation that I haven't seen really in Edexcel exams, but you never know. They may come up with this question. Now, let me give you the idea. Let's suppose they give you the same compound and they ask you to find the percentage of carbonate ions in there. And the whole carbonate ions have this formula. So what do you think how you will find out the percentage to this one?
Mm, I don't know.
Okay. Remember, this charge really doesn't matter because these are electrons lost again, and they really don't matter when it comes to masses. Electrons are so lightly charged. Okay, this is the portion, and we need to find out the percentage of this one. So this one over here is right, this part, right? So this is the MR. If you take this part separately, you can always calculate it. So 12 plus 3 into 16, which is really easy. 3 into 16 is going to be 48 plus 12 is equal to 60 multiplied by 100. And there you go. 60 over 106 multiplied by 100. And the answer would be a little less than 60%. So that's how you do it. Whichever ions are given there, you can just can't just find an element. You can even find ions. You can even find the whole portion.
Mhm.
Okay, so don't get confused by just this manipulation or a change in question. For example, you already calculated this part in Mohr's salt, the big question I gave you last time. Now, what if they ask you that to find the percentage of sulfate ions in there, SO4 negative 2 ions in there? Now you have three of these ions in there. So you calculate the MR, and you act what you do is that you have 3S plus you have 12O, and you divide them by MR and multiply them by 100. You'll get your answer. Do you get the point?
Yeah, yeah.
Okay. Since there are three sulfur and 3 into 4, there are 12 oxygens. That's why we have 3 sulfur and 12 oxygen over there. Okay. Another change in questions that Edexcel might make is that we recently did a question of CuSO4.5H2O. You're familiar with that formula. We recently calculated its MR on the same page to be equal to 249.5. Now,
Mhm.
what if the examiner asks you to find the percentage of water in this? How would you do that? It's pretty easy. 5 into water molecules, and you divide it by mR into 100. That's how it goes. Remember, this number also matters, not just the subscript one. Okay. So we know
Mhm.
that water is 18, so that would be 5 into 18 divided by 249.5 into 100. That would be equal to 90 over 249.5 into 100. And I guess it would be a little less than 36. It would be 36 point something, around 36%. It may be a little less than 36, but it would be really close to 36 if you find this one out. So if you go with these examples, you do understand that it's not just the elements they can ask for. They may ask about ions, they may ask about entire molecules such as water molecules. And the process does not change. It's still the same formula. We're still taking MR at the bottom. We're still multiplying it by 100 because it's percentage. It's just this part that we need to change, which I changed over here or here or here. I hope you get the idea how I changed those.
Yeah.
So it really enables you to come up, answer any kind of question the Edexcel examiners may come up with. Now, this really clarifies what we did last time. So let's move on. Let's go with the concept of mole. Now, before I go with the concept of mole, and your book really jumps into the concept, I usually tell my students a little bit of a background story. Now, in chemistry, mole is the unit of amount of substance. How much is the substance? Now, the substance can be considered in many ways. For example, I tell my students that mole is a secret chemist unit. Chemist knows how to go back and forth with mole. And why do we keep this unit? We keep this unit because we have to deal with a lot of different things in chemistry lab. Just like you deal with a lot of different things in your life, or a kitchen can be a very good example. Let me clarify myself. Now, you go out to buy grocery on many different days, and those grocery items may include things for which the amount of substance might be calculated very differently. Let's take a few examples to clarify ourselves. The first way we uh, buy things is based upon math. There are many things that you go out to buy in terms of math. Well, most of the things you buy in terms of your grocery are either weighed in grams or kilograms. Sometimes you buy cakes, since being a British tradition, we still buy our cakes in pounds, neither grams or kilograms, right? So I hope you understand that we sometimes go with weighing things and masses, right?
Mhm.
But that's not the only way, because as soon as you go out of this math section and you go to the beverages section, name a beverage, Coke, Sprite, Fanta, Seven, and name a beverage around the world, the beverages are usually available in volume. You get them in different volumes. I hope you understand we have 250 ml, we have 500 ml, we have 1 liter, we have 1.5 liters, we have 2.25 or 2.5 liters, and then there are so on and so forth. You have found out many different sizes in which the Coke, Sprite, Fanta, or other beverages are available, and these are all volume. Volume is usually taken in milliliters or liters, right?
Mhm.
So that's not the only thing. Now, it doesn't really end over here, because in some things we really go for the counting or numbering. Let me clarify. Eggs as an example, bananas as an example. I hope you understand we do not weigh bananas, we do not weigh eggs, we do not take their volume in milliliters or liters. What we do is that we usually go with a dozen count. Dozen means 12. We buy 12 eggs or multiples or small multiples of 12, 6, 3, 6 eggs, half a dozen, 12 eggs, a dozen, 24 eggs, 2 dozen. We go by that way. We do the same for bananas. In some countries, we do the same for oranges or apples as well, right? So
Mhm.
it's not just mass and volume that we go for. Sometimes we count them in numbering. The same thing happens in chemistry lab. Now, last but not the least, some things are actually solutions, so they are taken in concentration. For example, if you are feeling sick, you go out to the pharmacy and you buy a syrup. Let's say you are having cough, you buy a cough syrup, or you were having fever, you bought a fever syrup. Well, there are tablets available, there are capsules available, there are sometimes syrups. If you look at the syrups, syrups are actually done as solutions, mostly the solutions in water, and they are done in concentration. Not just that, most of our fruit juices are also available in concentration. They tell you right on the top of that fruit box or fruit package that this has a 7% fruit content, this has a 30% fruit content, this has a 50% fruit content. Name the company, even the biggest companies in the world quote the percentage of fruit juice in that nectar or in that juice right then and there on the fruit box. So that's concentration. So that means there is definitely some water in there. But apart from water, you also get some of the fruit. There would also be sugar and some other additives as well. So if we talk about our life, or if we talk about chemistry, there are four major conversions that we require. Now, we can't keep going with just one type of system, because that doesn't work that way. We can't completely work with it, because you can take masses for solids, but what about liquids or gases? For liquids or gases, you might have to consider volume. For some things, we don't even weigh them, we go for the numbering. And for concentration, you can't really go for mass or volume. You have to work with the concentration given whatever the units are. We'll discuss that a little later. All right. So mole is actually a central unit. Everything can be converted, all these different units that you can see, grams, kilograms, pounds, milliliters, liters, numbers, or the percentage or other concentration units can all be converted into mole, into a single unit, into a single way of of getting amounts of substances. That's what makes the concept of mole a little bit difficult for the students to understand, since there is a little more learning curve. I'm not calling the concept difficult because you won't be able to understand it. I'm calling it a little bit difficult because there is slightly a bigger learning curve involved. It requires a little bit more time, but as soon as you understand it, you really appreciate the intelligence of scientists that coming up with a single unit that can be converted into so many different things or so many different types of quantities. So what we do is that whichever masses we have discussed previously in terms of ARs and MRs in periodic table, we're going to take them as standard, and we're going to discuss them as the way for the conversion to mole, right? So
Mm-hmm.
let's go with that conversion and let's understand it in detail. The difference between expressing the amount of substance in moles or in grams is that one mole of any substance has its own particular mass, and it varies from substance to substance. For example, 1 mole of water will have a mass of 18 grams. 1 mole of sulfur will not have a mass of 18 grams. This saying the substance is different, so the mass would be different. 1 mole of magnesium oxide, the formula for which is MgO, has a mass of 40 grams. So the abbreviation for mole is MOL. We really remove the E and we call it an abbreviation. You notice that different substances or different species have different amounts in grams for 1 mole. So what is this mole exactly? Let's keep moving forward so that we can further define it. This was all a background. We're going to further elaborate it, right? So let's keep moving forward. I'm gonna lay a little bit of parts that we don't require up ahead. So we can therefore talk, for example, an amount of water as 36 grams or 2 moles, or since 1 mole of water has 18 grams of mass, same goes for sulfur. We can go for a higher mass or a lower mass. The quantity in moles of will obviously be changed. 1 mole was equal to 32 grams, 1.5 moles will obviously, if more than that, of course, that would be 48 grams. That's not written over here, but since I can calculate it, that's why I'm telling you. So some people talk about amount in moles, others talk about number of moles. This is like talking about the mass of substance or a number of grams. So don't worry when they go for grams or they go for moles. We are going to make the whole thing really easy for you. So you can find the masses in a mole of substance, and that's really easy. What do? Whatever the relative formula mass of substance would be, you take that amount and you attach the unit gram to it. There you go. You have the mass of substance in grams for 1 mole of substance. That's how easy it is. Let me clarify myself. Let's suppose you want to calculate 1 mole of oxygen gas in grams. So what do? Take this formula, calculate its MR, write grams next to this MR. There you go. That's the mass of oxygen in 1 mole of oxygen. That's how easy it is. Make sense?
No.
Let's do more examples to make more sense out of it. Let's suppose we want to calculate 1 mole of calcium chloride, or how much mass will there be in grams in 1 mole of calcium chloride. Let's say we want to take 1 mole of calcium chloride. How many grams will we take for it? So look at the formula, calculate the MR. This is the value of MR. Take that exact mass in grams, and there you go. You have 1 mole of calcium chloride. That's how easy it is. So for 1 mole of any substance, the mass in grams is equal to its MR.
So, sir, whatever the MR is, will just put gram.
We'll just put grams next to it, and that exact value is the mass for 1 mole of a substance for any substance on the planet. So that makes it really easy. Calculate the MR, take that many grams of the substance, you have 1 mole of the substance. Let's do one more example. 1 mole of iron 2 sulfate crystals, which have this formula. How much mass do we need to take in grams to have 1 mole of the substance? So we calculate the MR. And the entire MR turns out to be this. We put the value of grams next to it. That's 1 mole of iron 2 sulfide crystal. That's how easy it is. But this again, this whole practice becomes a little bit difficult. So the importance of quoting a formula to make the whole thing easy. This calculation is still a little bit difficult. So if you quote the formula, the whole calculation will become easier. Let's keep moving ahead. I'm going to erase all of these parts and we're going to come up with a formula to make this thing more easier for you. All right. But so far, whatever you have understood, that's good for 1 mole of a substance. But what if we need to take more? Okay. So if we need to take 1 mole of oxygen atoms, O is equal to 16 in the periodic table, write grams next to it. 16 grams would be equal to 1 mole of oxygen atoms. If you have 1 mole of oxygen molecules, the formula for molecule is O2. The mass would be 32. Take 32 grams of oxygen, you have 1 mole of oxygen molecule. This is another example for the same thing, but the formula is yet to come on the next page. We're going to see a few triangles, and working with those triangles is going to be really easy. Now, that's the formula you are going to memorize.
Mhm.
All right. So,
Yeah.
how do you find the number of moles of a substance? The unit of which is mole itself. You take the mass in grams of the substance, you divide by the mass of 1 mole. And the mass of 1 mole is something that we just understood how to take that. Sometimes instead of mass of 1 mole, we use the word molar mass. It means the same thing. All right.
Yeah.
To be 100% correct, that these are not same things and have slightly different units, but this kind of differentiation will not be asked at IGCSE. All right. To be
Yeah.
exact, the one at the bottom has the units of gram per mole, but even if you mention gram or gram per mole, it really won't matter. So let's suppose you need to take, that's what we have been doing previously. You need to take 1 mole of this. So how much mass will you take if you have 1 mole of this, right? So let's talk about copper sulfate 5H2O. How much mass will you require if you want to have 1 mole of it? Now remember, the MR of this one was 249.5. So how much mass do you think you need to have 1 mole of this substance? Mass in grams. Come on, that should be easy. We have been doing this. So what do you attach to the MR?
Gram.
Gram. So what's the MR? How many grams will you need to take?
249.5 gram.
That's it. If you take 249.5 grams of copper sulfate, you'll have 1 mole. Why? Notice, if you take 249.5 grams, notice, what is the mass of 1 mole? This really is MR. Don't get worried about this one. This is MR. So the MR was itself 249.5. The unit to this one is gram per mole. Notice this and this cancels for 1. This and this cancels. This goes upstairs, and there you go. 1 mole is equal to 1 mole, right?
Yeah.
That's what this formula has been all about. So since there are 3 values in this formula, we give it in the form of a triangle. So it makes the whole thing really easy for students. If you need to find the mass, the upper pyramid says something you need to find. You need to do this for these.
Mhm.
Okay. If you need to find
Yeah.
number of moles, you need to divide this by this. If you need to find mass, you need to divide. Sorry, if you need to find MR, you need to divide this by this. This is what these triangle means. With something that has three values in a formula, these triangles can be really helpful. Make sense?
Yeah.
This means, this line means division, and this is the multiplication sign. If you need to find this one, multiply these two. If you need to find this one, divide these two, because this sign meant division. If you need to find this one, you need to divide these two, because this sign means division. That's how easy it is. If you remember this formula, you don't need to remember any of these triangles, because the formula and the triangles are the same thing.
Mhm.
All right?
Yeah.
Okay, let's keep moving. I'm gonna erase a few parts that I don't really require. I'm gonna erase this, also this. Okay, let's take the same example, but this time we are going to do it slightly differently. What if you need to have 2 moles of copper sulfate? How much mass are you going to take?
First, we'll find the MR, right?
You already know the MR, that's 249.5, so you don't
Mm,
really need to go with that hassle. Remember, mass is something you need to find out. So in order to find out mass, this triangle is really helpful. And remember, mass of 1 mole is MR.
mhm.
How many moles you require? That's I've already given as a part of question.
So we'll just multiply it.
Exactly. So what would your answer be? If you have a calculator with you, that should be really easy. Taking that 2, multiplying it by 249.5, the answer should be
499.
499. Perfect. So you take 499 grams of copper sulfate hydrated, and you will have 2 moles of it. Let's suppose you need to have 10 moles.
2495.
Perfect. What if you don't need this many number of moles and you just need half a mole?
Um, 124.75.
124.75. Perfect. What if you only need 0.001 mole?
0.2495.
Perfect. So you already have an idea how to do it,
Mhm.
right?
Yeah.
Okay, let's do it a little bit differently. This time, you're going to tell me the number of moles you have, and I am going to give you the mass. Let's suppose instead of taking these moles, let's suppose I took 300 grams of it. Now you're going to use this formula. How many number of moles do you have for copper sulfate if I gave you 300 grams of it? Remember, you're going to take that mass and you're going to divide it by MR. This is
One.
MR, this means division.
One.
Sorry?
One.
No. 300 divided by 249.5 is not 1.
Oh, okay. One. Second. Yeah.
The mass is given in the question. MR is something you already know.
1.2024048.
Let's just stick to uh, 3 numbers after decimal or 2 numbers after decimal. That would be good enough. So it's
1.2 1.202.
1.202. Great. This means there are 1.202 moles in 300 gram of copper sulfate. This time I really took a small amount. I took only 10 grams of copper sulfate. How many number of moles do you have this time?
0.040.
0.040. Great. Okay. And let's say this time I took a huge amount. I took 12.34 kilograms of it, not just grams, kilograms of it.
So first we'll convert this, right?
First, you convert the kilograms into grams, and then you go ahead. Perfect answer. So, how many grams are there in 1 kilogram of a substance?
Divided by. Sorry, it's 49.45.
49.45. And I'm pretty sure that you took to 12340 and you divided them by 249.5. Is that so?
Yeah.
Good. Then your answer seems to be correct. Okay. Now we have done a great deal of questions. Now let's find it up since we have less time left. So I'm gonna erase everything over here. Okay. So now you see this whole formula has been changed into this sort. And there can be really three different questions about it. Examiner can either ask you the mass by giving you number of moles or the MR. He can ask for number of moles by giving you the mass and MR, or he may ask about the MR by giving you the mass and number of moles. Now, this kind of question are really rare. So mostly the questions are about this one and this one. Why? Because as soon as he tells you the name or the formula of the substance, calculating the MR from the periodic table is no big deal. So either he's going to ask you the mass by giving you the number of moles, which I did in the start, and either he's going to ask the number of moles by giving you the mass, which I did at the end, the right-hand side and the left-hand side question, right? I never
Yeah.
practice this sort of questions because you will seldom see a question about it. So let's clear everything else and let's give you a few questions. Now, question one, convert mass to mole, right? Remember, a few things that you need to understand and remember for mass, we need a few scales. 1 metric ton is equal to 1000 kilograms or 10 raised to power 6 grams. 1 kilogram is equal to 1000 grams. 1 milligram is equal to 10 raised to power minus 3 grams. And 1 microgram is 10 raised to power minus 6 grams. So I've told you bigger units of grams and smaller units of grams so that you can do the conversion whenever and wherever required. Make sense?
Yeah.
Okay, we sometimes write tons as tons and not metric tons. So you may see just the word tons written over there, or maybe the whole word metric tons. It means the same thing. Okay. So part A, 100 grams of ice. Remember, ice is water. Water has the formula of H2O. Okay. Part B, 13.48 kilograms of table salt, the formula for which is NaCl. Remember, you'll need to calculate the MRs in order to get it right. Okay. And finally, we had 0.835 kilograms of dry ice, which is actually carbon dioxide in solid form. So there you go. You have the formula. Now let's go with a little bit of change of a question. You're supposed to convert moles to mass, and whichever unit I've asked, you're supposed to do the same. So you have 1.12 mole of sugar, the formula for which is C12H22O11, the sugar we eat every day. And then you have, let's say, 0.01 mole of NaOH crystals, and C, you have 1,001 mole of Al2SO4 price salt, right? There you go. Take these questions as a homework. You'll know how to work with more. And most of the time, this would be a 1 or a 2 mark question. And if you are going to pick up your previous papers, you'll see this 1 or 2 mark question is a part of almost every paper every season, be it a June paper or it a January paper. Uh, Moles is definitely a part of the exams. And these questions will get you to work with many different kinds of things because you'll notice in all these 6 examples combined, I haven't even repeated any single substance. So every time you deal with something different, you calculate different MR. So it would automatically be a practice of calculating MR from the periodic table along with converting either mass to moles or moles to mass. Now, the previous diagram I drew it on purpose. You'll understand how to work with moles in conversion to mass, then into volume, then into numbers, then into concentration, and that's what this whole chapter is about. Step by step, you'll start to learn to work with all of them, right?
Yeah.
Can I erase these and move ahead? Or are you still writing?
And answer.
So take your time. All right, so now you know how to solve the question. Let's move on. So they're going to give you more questions. Find out this many moles of calcium carbonate. You need to find the mass or find the number of moles in this many grams of water. But these questions are really easy. So what I've done is that I've given you more difficult questions and more number of questions. You can either go through with these questions first and then solve the ones that I've given you before, or you can do them after. It's totally up to you. A couple of hints that we should do. Don't get too reliant on learning formulae for doing simple calculation. If one mole weighs 100 grams, it should be fairly obvious that 2 moles would be twice as much, 10 moles would be 10 times. I'm already done with this practice, so you won't have a problem understanding this. I've already asked you to go for 2 or 10 or 0.1 or 100. You already know what to do. Hint, if one mole weighs 18 grams, you need to find out how many 18 goes into 54. So of course, you can take that 54, divide that by 18, you'll know how many moles you have. You can do that mathematically, or you can use the formula. Remember, it's safer to use the formula, so you can always use it. So instead of going with how many 18s are into 54, he took the formula and divided 54 by 18 and got his answer as 3. So putting the values in the formula is a much more easier thing to do than to just go with it. The next one in the book is number. First, he talks about math, then this extension work is all about numbers, how to convert numbers into mole. We'll go with this one. Once we're done with this, they don't really go for volume and concentration after, they instead change the topic. We'll first go with some different topics before we can really get to volume. So you'll see that there are many different topics in here before I really get to the volume part. There are many different kinds of regulations before we go with the volume. There is a lot in this part of the book. Yeah, this is all based on masses. I guess the volume is in the next chapter. Then
Mm-hmm. Yeah, it's in
let
the
me just
next step.
check. Yeah, as soon as we start next chapter, there comes the volume part. Once they go with volumes, they'll be done with volume. They are going to move with concentration. So concentration is the fourth part they're going to go with. And as soon as they're done with the concentration, there comes the titration, which your teacher did, which we are also going to do, but that's the very end of this chapter. And soon after this, the whole thing ends. So you'll notice that the entire chapter is all about these four different kinds of calculations and how to work with these in detail and solving different kinds of problems. So let's stop right here with masses, and we're going to, in the next sitting, work with numbers, right?
Yeah.